Hello everyone, welcome back to LevelUp NJ. Today we are tackling another important Leetcode problem, jump game second. So in this question we need to find the minimum steps to reach the last index of the array. So let's break it down step by step and then we'll understand about this problem. So let's understand the description part of this problem. So you are given a zero indexed array of integer nums of length n. You are initially positioned at num0. Each element's num size represents the maximum length of a forward jump from I. In other words, if you are at nums I, you can jump to any nums I plus j value. So okay, understand. And then return the minimum number of jumps to reach n minus 1. The test cases are generated such that you can reach nums n minus 1. So this is kind of mandatory that you will definitely find the last index according to this question. So basically the question asks us to reach the last index of the array by making the minimum steps, and the every element of this array is represent the maximum steps we can take further. So now let's understand the example cases now. So we have 2, 3, 1, 1 and 4. So the minimum number of jumps to reach the last index is 2. 2 is the output. Jump first step from index 0 to 1, then 3 steps to the last index. So what did he do? At index 0 the value is 2, and as per the question, 2 is the maximum jump we can move forward. So either we can move 1 and either move 2. This is the 0th index, or first index and the second index. And we have to find the minimum steps to reach the last index. So in previous video, I discussed about the greedy algorithm, and also I discussed a question which is a kind of similar question. So this is the upgraded version of that question. So this question, so what I discussed about in that video, like you will find any greedy algorithm problem, you will find the kind of objective. So in this question we have the objective, the minimum number jumps. We have to find the minimum number of jumps to reach the last index of the array. So this is kind of the objective. So we will can understand like the greedy approach is being used to solve this problem. So as per the greedy algorithm, we have to find at each index or maybe each steps the maximum reach in order to getting the minimum number of jumps to reach the last index. Now let's understand. At index 0, either we can move index 1 or index 2, but if you uh, get index 1 which is 3, so 3 is greater than 1, so you can, if you choose 3, you can move forward and move farthest than rather than the 1. So that's why first we will think about and we will try to find the maximum value within the step at particular index, like for example 0, which is value 2. So for that particular index we will choose the index which has the maximum value. Okay, so at index 0 either we can move like 3 and 1, so we will choose 3 because 3 will help to move forward rather than the if we choose first. So yeah, this is about the description part and example cases. Now let's write down this problem and then we will think. So first we will create a count variable which will help to track the minimum steps to reach the last index of the array. So int count 0, and we will make another variable which is the farthest, initially is 0. So what farthest it's basically the maximum uh, value at that particular index. Like for example index 0, we will try to find the maximum value between the steps. Like here 3 is the maximum value. Now another variable which is jump index, we will make a loop I is equal to 0, I less than nums dot length minus 1 and I plus plus. Then we will maximize the farthest one. So farthest point math dot max farthest comma I plus means that value. Then we will make a condition if I is equal to, then we will make count plus plus, and we will change the value of this is it. And at the end we will return count. Yeah, this is, so let's understand line by line. So int count will help track the minimum steps to reach the last index of the array. The farthest, as we discussed in the question, we will choose at every index we will choose the maximum value and jump index range. So this is a point where we must improve the range of that index, and then this is the simple loop which will iterate over the array. And so farthest, as we discussed, we will choose the maximum value. So farthest will store the maximum value, or this is the maximum steps we can move further in the array. And if I equal to jump index range, then we will count plus plus, and we will change this variable with the farthest one, and then at the end we will return count. So yeah, this is the problem. So, and the time complexity of the space complexity, like we have done this is linear time complexity and this constant space complexity with the help of greedy algorithm, because greedy algorithm always gives you one of the best optimal solutions to solve any problem. Let's try to run it. So there is an error we are getting. Shit, no mistakes. It's done. Let's submit it. Yeah, it's done. So this is the question in which the greedy algorithm is being used, and we have done that. And so if you don't know the greedy algorithm, just watch my previous video. In that video I explain all about the greedy algorithm with the example cases. So yeah, this is all about this question and this video. Please like, share and subscribe LevelUp NJ. And if you've got any kind of doubt, just comment below, and see you in the next video.